again. Hi, everybody. Hi. That's still pretty terrible. Not great. Not great. Not gonna lie. Not good. Okay. We have very little time and so much to get through. So, as always, we must dispense with the most important business first and foremost. We're going to take a selfie. It's going to be awesome. So, when I say open source, you say open source. You pretend to be happy, and then you smile, okay? And we're going to take a quick photo. Okay, hold on. Wait, we don't need flash. That won't help anybody. Ready, steady, open source. Oh, yeah. Oh, yes. And open source. Oh, what is... Do they not put any caffeine in the coffee here? What's the deal? Lunch? Oh, well, okay, well, it's fine, it's fine. All right, we don't have a lot of time. So the goal, as always, is not to remember every single keystroke and remember what I've typed, but it's instead to appreciate what is possible. So, as a result, note that repository there. That Git repository has all the code that you need to be able to follow along later on at your own time, at your own leisure. Also, there's my Twitter coordinates. So if you have questions, if you have comments, if you have ideas, please feedback. I'm very happy to hear from you. I really am interested in being able to help in your journey as we move forward in time, so don't hesitate to reach out to me. Also, my email. So again, lots of options here. Please don't hesitate to reach out to me. Regrettably, I have a flight at 4:30 today, so I'm not going to have a lot of time for questions afterwards. I'm happy to engage, as I say, on the internet. Don't hesitate to reach me there. A little bit about me. My name is Josh Long. I work on the Spring team. They made a toy out of me in China. I think that's kind of cool. I'm on WeChat if you're in China. There's that. I have videos on Safari, lots of different technical content. It's an all-you-can-eat technical marketplace, kind of like Netflix, except you don't get stupider, so that's nice. I have a book called Cloud Native Java, and available in a number of different languages. Who knows? Maybe it's available in Polish. I don't know, but these are the 4 that I know about, so that's cool. I have a podcast every Friday. I do a new installment of this podcast called A Beautiful Podcast, which talks about, interviews people in the ecosystem, right? So every Friday, iTunes and Google Play and all that stuff. It's available everywhere. I do screencasts every Wednesday, so that's today. A new episode came up just today on Spring Tips playlist on YouTube. And of course, I have a new book called Reactive Spring. And that's really what we're going to talk about today, is building reactive applications with Spring. Reactive Spring, when I talk about Reactive Spring, it's a new response to an old problem. That problem is, how do I scale? How do I handle more users? Traditionally, if we wanted to answer that question, it was very simple to answer the question. We would just add more threads, right, to a single machine. And of course, at some point, we realized that threads are very expensive. They're not scalable. They're not infinite. And it's hard to add more of them to a single node on a single computer. So we moved to microservices. We moved to 12-factor style applications. And this architecture style emphasizes the removal of state in a given service. The idea is that you make it as cheap as possible to stand up more instances of that service. And as you do that, you can put that inside of a load balancer, and then the load balancer can distribute the work across the number of nodes in the load balancer ensemble. So this is an obviously sort of natural progression, and it has served us okay. But the question is, could we have done better? Could we be more efficient? Could we do more with the same computer? And the answer has not been very satisfying, right? The answer has always been, well, not really, because we're using threads. The traditional approach to input and output is based on our allocation of threads. We have 1 thread per request. And that model, while it has worked well for applications in yesterday that are based on synchronous and blocking input and output, that model doesn't need to continue. It doesn't need to be that way. So the question is, how do we embrace, or how do we alleviate some of the contention there involved in threads? If the work that we're doing on those threads is input and output based, then we have an option. We have an opportunity here to do better. If that work is input and output based, if it's CPU based, if you're doing Fibonacci or cryptography or Slack or something like that, where it just wastes all of the resources, right? Then there's not really an option here. You're going to the only way to scale that out is to have more threads. But if it's I/O based, well, there's some option. One option is asynchronous I/O. Asynchronous I/O changes the way we think about input and output. Instead of reading data from an input stream and then just sitting there waiting for the data, waiting. Instead of waiting for the data on that thread, you instead ask for the data. And as the data becomes available, you get a callback, an interrupt. And that callback has the data that you're asking for. But in the meantime, while you're waiting, you're not actually sitting on that thread anymore. You get off the thread, and then somebody else can reuse the thread. The benefit of this is that now a scheduler can move work onto the thread just long enough for you to initiate I/O, and then you get off the thread immediately. And the data, as it becomes available, will come back in an interrupt later on. This allows more work to be done on those threads, because you get what's called an event loop. And if you work with this approach, it's a very complicated approach, but it is a much better scale, right? You can handle a good deal, many more requests on the same computer. What about asynchronous I/O? Is this an option for us on the JVM? Well, of course, right? We've had support for asynchronous I/O on the JVM since at least Java 1.4. Anybody here remember when Java 1.4 came out? Right? 1.4 came out in 2002, 17 years ago. So the question is, why aren't we all using that, right? And think about that. Think about what that means. If it's available in Java 1.4, that means it's available on every, That means it's available on every operating system on which Java runs since before 2002 in a consistent way, right? You've been able to use asynchronous I/O in some way or another on every major operating system, even Windows. Windows. Imagine. Wonders never cease. So, we now have this thing that's available to all of our operating systems. We have it in Java 1.4 and later, 17 plus years, the very large majority of Java's history. And yet, most of us, I expect, don't use it. And to be fair, most of us haven't had a need to use this, right? We haven't had to think about it. Most of us have been building monolithic applications where you send a request, a user clicks on a button and sends a request to the server, and then it loads an HTML page, and then you're done. Nothing happens until the user is done with that page, and then they send another request back to the server. It's not the client-server world that we see today, where you have iPhones and Android devices and HTML5 browser devices and smartphones and smart cars and all this kind of stuff, where now every single interaction with an app can result in 10 other calls to the services, right? Service-centric architectures result in a lot more input and output, a lot more chatter over the network. This new approach is what makes us see the sort of inherent inefficiency in our traditional approach to input and output. It's only in this new world that we have to think about how to get more efficiency, more performance, more scale. And so asynchronous I/O can give us that, but it is a little bit complicated to use. And more to the point, it doesn't map naturally. It hasn't mapped naturally to the way we think about our code or in our business logic. Traditionally, we think about things in terms of Java util collections and these kinds of types that we know about. And they work just fine, right? All these technologies that you know about, things like Spring and Hibernate and so on, these things work in terms of these sort of synchronous, finite, limited types, these things like Java collections. Now imagine for some reason, just imagine, a hypothetical, okay? Imagine that for whatever reason, Hibernate really just did not like Java util sets and Java util lists. It didn't just dislike them, okay? It didn't just throw an exception. Imagine, hypothetically, that whenever you tried to use a Java util set or Java util list with a Hibernate mapping, imagine that it didn't just throw an exception. Instead, every single time you did this, it rendered an ASCII art middle finger and then segfaulted the machine. Would you continue to use a Java util set with Hibernate if you knew that you could expect this kind of abuse? Of course not, right? You'd use something else and continue using Hibernate because you still have to deliver software into production. You have to deliver business value for your business. And so you just use whatever is the path of recommended sort of least friction. So whatever that is, you'll use that. The same applies here. We have an opportunity to use reactive programming to alleviate our problems with scale and to build systems that are more that handle scale better. But whatever types we use, they have to be well supported at every layer in all these different frameworks that we think about and we care about. And so this is where the journey for the Spring team came. In 2017, in September, we released Spring Framework 5. That, in turn, introduces a reactive baseline, on top of which we have since released Spring Data K, Spring Security 5, Spring Boot 2.0, Spring Cloud Finchley, and so on. And so, my friends, today we're going to talk about a little bit of all of that stuff. Here, on the Spring Initializer, hopefully, we're going to start our journey here. Let's see. There we go. Good stuff. So, we're going to build a new application here, my second favorite place on the internet after production. My first favorite place on the internet, of course, is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather is amazing. It's the happiest place on earth. It's better than Disneyland. But if you have not been to production, you can begin your journey here. Let's start. That's spring.io. If you need inspiration in the early morning before a cup of tea or coffee, start. That's spring.io. If your children are restless and cannot sleep, start. That's spring.io. And if you suffer from indigestion after a long night of alcohol abuse and WebSphere, start. That's spring.io. So we're going to build a new piece of software today called the reservation-service. Just a new service, reservation service. And we're going to use certain types from the Reactive supported libraries in Spring. We're going to use Lombok. We're going to use Reactive MongoDB. I'm going to use, let's see, I think that's it. I want OurSocket as well. So I'm going to use all that stuff. We're going to pull that all in. I'm going to hit Generate. And that's going to give me a brand new project. I'm going to open that up. That'll give me a brand new project here. I'll open this up here. And, come on. Go, 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 go. All right, waiting for, yeah, no kidding. Waiting for 9, Cat. Is he okay? All right, good. So we have a new application. And the application is we just started it up, and our goal is to write data to our database. I'm running MongoDB, it's in the background. MongoDB is one of the many supported modules in Spring Data that have natively asynchronous drivers. And so we can use those drivers to build Spring Data abstractions, but that is not true for everything. Right now there's 4. There's Cassandra, there's MongoDB, there's Redis, and there's Couchbase. There's work, as far as I know, and I could be wrong, but I think there's work being done on Neo4j and Elasticsearch to have a reactive option soon. But for now, we have these 4. These are the production-worthy NoSQL options. And I'm going to use Spring Data MongoDB, the Reactive Spring Data MongoDB module, to write data to the database here, like so. I'm going to create an object that has, I'm going to create an object that has getters and setters and all that kind of stuff. So I'm going to do this, and oh, so modern. Look at all that good stuff, right? All that good stuff. Okay, I can do that if I want, or just use Lombok, right? So Lombok, like so, okay? That's better. That's a compile time annotation processor. And what I'm going to do now is I'm going to create a repository. A repository is a thing that writes data to the database. So it's going to be a thing that handles the boring reading, writing, and updating and deleting of data for me. And a repository extends from the Spring Data Reactive CRUD repository, and that supports automatically a lot of the common lifecycle management methods in your data access tier. Things like saving, finding, flushing, counting, etc. You can recognize by these names what they're meant to do. I think that's pretty obvious. But what isn't obvious are some of these types. First of which is publisher. Now, remember I said that we have to have a set of types that are pervasive, that are well supported at every layer of the Spring application, at every layer of any application in general. So a number of companies, several years ago, we got together and we created something called the Reactive Stream specification. The Reactive Stream specification provides 4 very simple types. It is a joint initiative by Pivotal, by Lightbend, by Netflix, and by the Eclipse Foundation, among others, to define these 4 very simple reactive types, common ground across all these different projects. A publisher is a thing that publishes items of type T to a subscriber. When the subscriber receives new data, the data is passed into the onNext method. When there are any errors, those are called errors, not exceptions, because remember, errors are not exceptional in reactive code, right? They're just another kind of data, and you process them with another operator in the same way that you process regular data. And then finally, when processing is completed, onComplete is called. Now, I skipped over this because this, onSubscribe and the subscription, is arguably the most important part. When I have a stream of data, I want to make sure that I have the ability to slow down the producer, to stop the rate of production. In the reactive world, this is very important. This is how you say, I just want X more records. I want 10, I want 1,000, I want whatever. That number is how many records I can handle at the same time, or possibly at the same time, without being overwhelmed. I'm asking the producer, I'm telling the producer, I can't handle any more than whatever number of records I specify there. This is how you ensure a robust system, so you don't get overwhelmed, you don't get denial of service. The benefit of this is that it's flow control, client-managed flow control, right? Just like a message queue. But it's not a message queue, of course, but it has similar architectural characteristics there. In the world of reactive programming, flow control has been called back pressure. So it's just marketing for something that's been around for most of a century, okay? Now, we've got that. Now we've got these 3 types. I said that there are 4. The 4th one is called a processor. Processor is a type that is a bridge. It's a producer and a consumer, and that's it. Now, I used Java 1.8 right here, but if I choose Java 1.11, or just 1.1 or 11, as we say, because I screwed that up, if we use Java 11, then you can see that there's another set of types on the class path now inside of the JDK itself, and that is in flow, right? So if I go to Java util concurrent flow, there you can see processor, subscription, subscriber, and publisher. These types from the Reactive Stream specification are so obviously useful that they're now in the JDK since Java 9, okay? So you can use either the Reactive Stream types in Java 8, which is the baseline for Spring Framework 5 and later, or you can use Reactive Stream types in the JDK itself. Now, those are useful. We also have mono and flux. A mono is a publisher from Reactor, our project, Pivotal's project, that builds on top of the Reactive Stream types. It provides a publisher. But a mono holds at most 1 value. It's like a completable future with back pressure. We also have a flux. A flux is a publisher from Reactor that implements publisher, but it provides 0 to X values, where X could be potentially unlimited. Okay? Now, these types, mono and flux, also provide operators like map and flat map and filter and all that we can use to iterate over streams of data. So now, I've got this repository, I've got these 2 types. I want to write some sample data to the database. Okay? So I'm going to create a sample data initializer. And this is going to be a thing that listens for an event. When the application starts up, I'll say public void go, and I'll write the data to the database, and I want to inject a reference to my repository into the constructor. I could create the constructor myself, but I'm lazy, and I prefer to let this Lombok annotation create a constructor and initialize storage for any final fields in my application. Now, normally, my friends, at this point in my performance, I would normally ask people in the audience for some names, but I have been to Poland before, and I know that that's not wise, right? I know that I won't get very far asking for names here in Poland. I tweeted about this yesterday. I always forget. I meant to bring some. I always forget to bring my vowels, right? Next time I come in. So that's awkward, right? People, my friend Marcin, he said, can you spare some? I could definitely add them to my last name, right? This is Grzeziak, right? So he needs some, and I was like, I really just need to bring some vowels. And so I'm not going to bother asking for names because I would do a terrible job spelling them. So I've already got some names here. There we go. Okay, so we've got some names. I'm going to create some names. I'm going to say names equals publisher of, and then these names, okay? These are some of my friends in the community, the open source community. I'm going to say names that map each name into an entity, a new object, passing a null like that. And that creates another publisher. This is a publisher as well, right? This is a publisher of string names, and that's a publisher of reservations. And I want to save it to the database. I'm going to say flat map each R, or each reservation, just R, into the database using this. So I'll pass that in. And that gives me another reservation of saved data. Now, this is a cold stream. Nothing has happened yet. I've initialized 3 stages in the pipeline, but nothing has been executed until you subscribe to the publisher. Like this, you subscribe. And that makes it a warm stream or a hot stream. So now it's active. Now, of course, I've created 3 intermediate variables, but I'd rather just chain them together like that, okay? And actually a publisher of reservations. And there we go. Now I've got some data. And what I want to do is I want to delete everything in the database first, and then I want to force that to finish. I want to make sure that that finishes, but I have to subscribe, right? I could subscribe, but keep in mind, subscriptions are asynchronous, right? So they could happen on a separate thread. So there's no guarantee that if I did this first, that this would then execute second. I could start this, and it would continue running while this is started. And that's not what I want. I could do block, but that's a terrible idea, right? Every time I do this, every time I see this block call in reactive code, it makes me want to take a shower. So that's not great. No. Instead, you use the operators like this. You say, then many, and you chain it together. And then I'm going to say reservation repository at find all, and then I'm going to finally log the results as they come out. So I'll say log for J, log, and I'll just log the results, all right? Good. So there's my application. Let's go ahead and start it up and see what we get. All righty. So there's my data. You can see our names on the console there. It worked. It went to MongoDB. If I go to MongoDB here, Mongo, db.reservation.find. There we go. There's our MongoDB data. So that's OK, right? That's just fine. Now, what I want to do is I want to instead, I like NoSQL. I like MongoDB. But a lot of people ask, well, can we use a SQL data store? And the answer has not been very satisfying until recently, because there was no good way to use JDBC, which is the common standard for SQL data access, in a reactive way. But there are some options on the horizon, one of which is R2DBC. So github.com, R2DBC. R2DBC is a reactive relational database connectivity API from, we started it at Pivotal, but there are a number of different drivers available for different technologies. There's PostgreSQL, there's Microsoft SQL Server, there's H2, and there's a third-party one by a project called JASync that supports MySQL. So I'm going to bring that into my application and swap out the code that I've already got. Okay? Now, keep in mind, this is not yet GA. Okay, there's not yet a GA-supported version of this, so I have to add the stuff into my code manually. I'm going to just do a little bit of configuration here. All right, bring that in, get rid of that. I'll bring in Spring Data R2DBC, get rid of this. Good. And now what I want to do is I want to comment out the MongoDB support here, and I'll just use R2DBC. So I'm going to change the code a little bit. Okay, so this is no longer a string, it's an integer, it's a monotonically incrementing ID. Private string name, okay, and the repository uses an integer. Okay, good stuff. And there we go. So now I've got that, and I want to connect my application. Remember, there's no auto configuration yet, so I have to do this myself manually. It's not a big deal, and we're just going to, I'm a little lazy, so I'm not going to extract out all the code into a separate object, into a separate configuration. So I'll say @enable R2DBC repositories, and I'll initialize a connection factory. So a new Postgres connection factory, and I'll use a builder. Here we go. Good. Now, this is just, we're friends, right? We're friends. So I'm going to just, username is orders. Password is orders. Don't tell anybody. Just us. Okay. Host. Local host, database name is equal to orders, hashtag YOLO, right? There we go. So, good. So there's my application. And if I restart the application, I should be able to go to pSQL, orders, and D, and select all from reservation. You see that I didn't type it correctly. Okay, and there's our data, right? So you can see the data has been written into the application, into the output there. Okay, good. So now we've got that. in the PostgreSQL database. Good stuff, right? We've done a good job there. Now what? Well, I want to build a REST API, and I could use Spring MVC style controllers, but a nice option in Spring Framework 5 is to use functional reactive endpoints like this. So you say bean, router function, server response, routes, return, and what I want to do is I want to say, let's inject the reservation repository, or I could even just do that in the provider method here, like this. Okay, and I can say route dot get /reservations, and I'm going to create a new handler function, and I'll say build. So handler function, reservation repository at find all. Okay, actually return server response.ok.body.find all, passing in a publisher of type reservation. So there's my functional reactive style, and good stuff. Okay, so we've got that. That just becomes a single one-liner. Add on demand static, good stuff, good stuff. Restart that. And this is going to work. Obviously, it's going to work as we expect because it's just a regular HTTP endpoint. It's a builder, so you can programmatically add new HTTP endpoints. If you want, you can use method references instead of lambdas, in which case the logic lives somewhere else and is testable, but all the routing in the application lives in a single piece of place, in a single piece of the code base. So that's nice as well. So localhost, reservations, okay. There's our data. Did I miss something? Where's the fourth one? For that matter, why didn't it write out? Did one of my characters break my... Sorry? Names is passed to here. Find all. Log. Delete everything. Is it because of this? Who's missing? Yeah, that's missing. Let's just see if I forgot to do Unicode or something. Oh, I hope that's not it. That'd be ridiculous. Oh no, something is very strange here in this early milestone release. Let's go back to that one. It's deleting data. It's like, oh dear, no. Okay. Not at all the result I was expecting. Okay. I'm not satisfied with that at all. Why is it 564? What is going on? Reservation, integer, ID, string name, deleting the data, saving it there. We got the repository, finding all the data, orders, host, database. Feels like that should be everything. Let's go to the build and make sure that it's re-imported everything. Maven, re-import, and I'm going to go to here, delete from reservation. There's one record. How curious. Sorry? Schema? This one? Oh. Nothing. One record, which is very strange. So I've got this name. Wait, let's just try, just for an example here. Sorry? The null? Oh, I need to, oh, maybe, yeah, it should be the ID column. Let's try that. I need to tell it to auto-increment the ID. Could have been. Maybe that's it. Oh, that's it. Okay, thank you. Oh, so happy to hear that. It's just me. Welcome back, my friends. Whew. Sorry? I can't hear you, my friend. Okay. We have now an HTTP endpoint. We have data in the database. Life is good. Moving on. One thing, this is very boring. This is a very simple example. I'm just taking data from a database and streaming it back. Much more interesting example is how do I write applications that are never ending, that are unbounded, that take advantage of this long-lived sort of reactive support that is more efficient. And so what I'm going to do is I'm going to create a greetings producer. And a producer is just going to be a thing that produces an object of type greetings response whenever somebody sends a request of type greeting request. So class greeting request, okay? And the response will be a greeting, and it'll be data at all args constructor, no args constructor, good. And it'll be a greetings request that has the name. So private string name. Okay, so what's going to happen is somebody creates they ask for a publisher of greeting responses, and they'll get back a stream of greetings responses whenever they send a request. So greetings request, here we go. And when I see that, I'm going to create a never-ending stream using the Java 8 Stream API to create a never-ending stream as a supplier. I'm going to create a new greetings response, and good afternoon in Polish. Oh, is that right? Okay. Okay. And we have to use the greeting request.getName at instant.now. Good. And that's just a reactive a lambda, and that's going to produce a never-ending stream. So what I'm going to do is I'm going to delay each value using the scheduler. Now, keep in mind, there is a scheduler behind the scenes here. That's what makes our code, that's what's moving the work from one thread to another. You can control that scheduler. For example, here, I could have said, I want to schedule this work on a particular schedule that is backed by an executor, right? Like this. So you could do that if you need to, but that's only if you want to manage the scale by adding more threads. That's good for existing blocking code, but you shouldn't need it most of the time. You can use the scheduler to add time as a dimension to your API. So now I've got the scheduler. I can do it. I can use things. I can do things with it to, for example, create WebSockets, right? I can say class WebSocket config, right? And I'm going to create a bean of type WebSocket handler, like this. Return new WebSocket handler. That's the business logic. We're going to come back to that in a second. It's going to have a bean of type WebSocket handler adapter, which is usually the same, but you can use it to configure your infrastructure if you want. And then finally, a bean of type simple URL handler mapping. And this is how you tell Spring how the endpoints get mapped to the actual running web server. So set order is 10, set URL map is map.of ws greetings, okay? And I'm going to map this endpoint, the one that I'm going to create here in a second, WSH, I'm going to map that to this URL here. Now, the business logic is in this WebSocket handler. When a client connects, I'm given a reference to the WebSocket session. I can say session.receive, and I'm going to get back the stream of WebSocket messages. I'm going to take each WebSocket message and get the text. That's the name that I want to greet. And then I'm going to flat map each name into a call to my producer, my greetings producer, the thing that produces a never-ending stream of data. So producer, and I'll say producer.greet, passing in a new greetings request, all right? So name. And what I have here, as a result of all of this, is a publisher of greetings response, all right? Add that, good. And I want to send back a response to the user. So I'm going to say greetings response.flux, map each GR into some text, right? And I'm going to map each one of those text messages into a WebSocket session text message, right, like this. And I'm going to send that whole thing back to the client, so WebSocket message. And I'll say session.send map. So that's the whole pipeline. I'm just taking incoming data, and as it comes, I'm going to send it back to the client. And of course, you can chain everything together if you like. It doesn't really need to be separate lines. Works just fine. Here's the response, reply, and there you go, okay? Cleaner, get rid of that. There's my whole WebSocket application. I'm going to send a request from the client. Okay, so there's this. In order to demonstrate this, I need to do something terrible, something that I'm not very proud of, but I do because I care about you and I want you to appreciate how to do this. I need to write some JavaScript. So source main resources static. And I'm going to create a little file here called ws.html. And here I'll say HTML script, body script. And I'll say window.add event listener load, function, E, and I'm going to create a WebSocket object, a client, ws localhost 8080 / and I'm going to use this endpoint called ws greetings in my code here, and I'll say add event listener load, open, and I'll also add another listener here for message. So when the data comes, console.log message, message.data, okay? That's the logger, and then when the WebSocket session is opened, I'm gonna actually send a message to the WebSocket. I'm gonna say send window.prompt who should we greet, all right? So I'm gonna ask the name, who should we greet, and then send the string back in the, into the WebSocket var name, like that. Okay, there's my little application. Let's restart that and see what we get. Good. Okay, localhost ws.html, Bob. Okay, console. All right, so you can see every second it's going to produce a new response in the WebSocket. Each time it produces a new value, it sends out the data, and then the thread is freed up and somebody else can use the thread. We're not wasting time on the server with one thread dedicated to this long-running process. So we can handle other requests in the meantime. Now, I have a service here. Let's go ahead and create a client, okay? Now I want to create a reservation client here very quickly. And here, I'm going to use, I want OurSocket. I want the reactive web support. And I think that's probably it, okay? So I'm going to create a client. And also, while I'm thinking about it, since we realized that it was my issue, I want to bring back M3. Good stuff. I like M3. All right. Restart that. And meanwhile, I'll go back to my console, my downloads directory, reservation client.zip. And this is going to be an API adapter, an API gateway. It's going to be a thing that calls into my downstream service. And so it's a great place to just exercise, making calls as a client. I'm going to run this on a separate port. So server.port equals 9090, for example. And I can do things here. I can create like a client for my iPhone or my HTML5 browser devices or whatever. They can go through this API adapter layer, and then that can be proxied to the downstream service. I could use projects like Spring Cloud Gateway. But let's just say I wanted to create a new endpoint that just had the names of the data in the downstream reservation service, okay? So I'm going to create a new functional reactive endpoint here, build, and I'll call .get. So when somebody comes here and asks for names, I'll provide a new handler function. With the handler function, then I'll need to make a call to the downstream service. So I'll create a reservation client. And the publisher here is going to need a type of reservation. So I'm going to do something terrible, something that you should never, ever do, ever, not even when you're all by yourself at home and no one is looking. I'm going to copy and paste some code. Okay. Here's this. And here's this. Okay, so I've got that there. I don't need the ID annotation. And I'm going to say, okay, when somebody makes a call, when somebody wants all the reservations, I'll make a call like this. I'll say, let's make a call using the web client, the reactive HTTP client called the web client. I can inject that in the constructor or use @required args constructor, @component. Good. And the way this works is I say .get.uri HTTP localhost 8080/reservation. So I'm going to make a call to the downstream service. I'm going to retrieve it, turn it each into a reservation, and then send that back. And I need to provide an instance of this object. I need to provide a bean. So I'm going to create a bean provider here. And this will just inject the web client builder. And I can customize this. I can add filters, for example, doing security and whatever. But in this case, I just want to build it. OK, so I've got the client. And now I can use that client here to make my call. So client RC, okay? So I say rc.getAllReservations, and that gives me a publisher of data. I'm going to say allReservations.map R to get name. That gives me a publisher of names. And I can send that back. I can say serverResponse.ok.body map string.class, okay? Very straightforward, but consider what I've just done here. I'm making a network call. Do network calls always work? Are they always going to be okay on the network? Of course not, right? There's going to be issues. So you can use operators. You can say, okay, I want to retry if it fails, or I can do a retry back off, right? Like this, back off, 10 times, and then escalate 1 second more each time you try, for example. I can also handle errors. I have these operators. I can say, okay, well, when something happens in the pipeline and it throws an exception, I'll return a fallback. I'll say flux.just eek, right? Providing a default value if something goes wrong. So you have a lot of operators here in reactive code to build more robust code. Okay, so there's one kind of endpoint. What about the other data? I showed you that the WebSocket endpoint. I want to stream data here over the network, right? What about other kinds of interactions? Here, I'm just doing a request response. I'm making a call from the client to the service. Very common thing to do, and this is an okay way to do it. HTTP works just fine, but a lot of high-scale microservices organizations, a lot of high-scale organizations are realizing that while HTTP is a great document retrieval protocol, it doesn't offer the best performance or the most flexibility for a lot of classes of architecture, a lot of classes of applications. So Google, very famously, they created gRPC. gRPC is a binary protocol, it's a network protocol, and it's meant to be language and platform agnostic. The problem with it is that it's asynchronous but not reactive by default. So a company called Salesforce created a reactor-based compiler plugin for gRPC. So you can use gRPC and get code-generated reactor-based services. That's kind of cool. There's another small company in the Bay Area called Facebook. I don't know what they do. Apparently, they're pretty popular. But they have created a thing called OurSocket. OurSocket is a binary protocol, and OurSocket is meant to allow them to handle other kinds of message exchange patterns: request response, fire and forget, message in, stream out, stream in, stream out, right? So bidirectional communication. It allows long-lived, multiplexed connections, so I can make a call to a service and then just keep the connection open. The cost of reconnecting is where people spend a lot of their time in your typical microservice environment. Once you've got a connection open, and especially if you're just sending very, very efficient binary data, it's not very slow at all. You can go very quickly. The other thing is that OurSocket as a protocol is built for the microservices world. It's got a frame in the protocol itself that describes the availability of a given service. So I talked to you about client-managed flow control and the ability for the client to ask the server to slow down. How can the client ask the server what its availability is, what its uptime is, what is the mean time to response for each node in the ensemble? If you can ask that question in a standard way, you get some very interesting options. So Spring Framework 5.2 supports OurSocket. OurSocket, of course, was led by people that came from Netflix and went to Facebook, people that worked on RxJava, people that worked on Hystrix and a lot of the other Netflix OSS stuff. So they understand the use cases of microservices organizations. As a result, this protocol is natively reactive. It's meant to be used in a reactive way. And so we have it here on the class path. I've got it right here. You can see it says Spring Boot Starter OurSocket. I'm going to create an OurSocket service here, okay? And in order to create that, you just create a controller. I'm going to create a greetings OurSocket controller, very simple example here. And it's going to be message mapped. I'm going to give it a string, which is a mapping endpoint. It's not a URL, but it's a message endpoint there. I'm going to say when somebody makes a call, I want to greet them when they send a greetings request, okay? And in order to do that, of course, I'll use my greetings producer, like so. And I'll just inject that, like so. So this .producer.greet, greetings request, voila, that's it. Now, in order to work, I need to start up the OurSocket server. So I'll say OurSocket server.port equals 7,000, okay? So that's going to stand up an endpoint on port 7,000 that maps to this service. And then I'm going to create a client on the other side. On the other side, on the client, actually, I think I might want to. They might have changed it. So for now, to be safe, and since we're running short on time, I'm going to go back to this. They're moving to a new encoding by default in Spring Boot. But right now, from M2, it's JSON, right? So you can use JSON over the binary stream. And on the client side, just to be safe, I'm going to stick to that as well. And we're going to create a OurSocket client. So here we go, OurSocket config. And I need to do two things. I need to create a OurSocket object itself, like this. So OurSocket factory.connect frame decoder mime type utils, okay, value transport TCP client transport.create. And what port did I say it was on the server? 7,000. Thank you. Good. Start. And here's that thing that makes me sad. Hate having to do that. Okay. And then I'm going to create a OurSocket OurSocket requester. So OurSocket requester, and I'll say OurSocket requester dot create, passing in that, passing in a MIME type of application JSON, and passing in the OurSocket strategies, which Spring Boot auto-configures for us. Okay, good. So now I've got this. Now I can create a greetings client. So class greetings client. And I'm going to create a publisher of flux of greetings response. Okay, greetings request. All right, and this will just be a regular Spring Bean. I'm going to inject the OurSocket requester here. Required args constructor. This.requester.greet, or .route greetings. That's the URL sort of thing that I used here on the server side, right? Greetings. And I'm going to say data is going to be the greetings request, and the response that I expect to come back will be greetings response.class, like that. And there we go. There's my client. So I can use that. And what I'm going to do is I'm going to take that greetings response and then send it to my HTTP client, which is running on port 9090, as server sent events, which is just another HTTP. It could be WebSockets, it could be whatever. But here, I'll show you how to do server sent events. SSE, greetings, and name, new handler function. And it'll be server response.OK. And we're going to use our greetings client. Okay, GC. So we say gc.greet new greetings request path variable equals name, and assign that to a publisher, and then the body will be the name value there, greetings response dot class. And of course, the only thing that I have to do from the server-side perspective is I have to tell the client that this is a content type of text event stream. So I'm using HTTP, and this is a content type that is meant to stream forever, but I'm actually sending Reactive OurSocket data that's coming in over the network. So I'm bridging it, if you will. Okay, so here we go. Run the client. This is going to be on port 9090. Okay, I think. Yeah, port 9090. So if we go to localhost 9090, and we go to reservations, names, there's the names, good. Now here's our service and event stream, world. And there you go, it's sending service and events, and I'm bridging it using OurSocket. So this is a new opportunity here, my friends. We can do some amazing things once things are natively reactive. Once everything is a publisher, you can pull together different streams of data. You could use Kafka, you can use OurSocket, you can use HTTP, and they all just become publishers that link up together. The real value here, by the way, one of the real promising things about this is the fact that we have disconnected the creation of the pipeline from the use of the pipeline. So imagine back here, right? I've got this thing that's creating a publisher here. Remember, nothing is being executed until you actually call subscribe. So I'm creating a cold pipeline. Now imagine that instead of doing this, I showed you some of these ways that you can build more robust systems. There's another pattern that's very interesting that I think you should know about, and that pattern is called hedging, right? So here, do get all reservations, string host, okay? So I'm going to take this code. There you go. And with hedging, what happens is you have a dynamic microservices environment, and in high SLA microservices environment, they can't afford to wait too long for a response. Okay? So they cannot afford to make a call to a downstream service that then fails. If the downstream service fails, then their client is going to be in trouble because they're going to be exceeding their SLA, their deadline. So what they do very commonly is they call multiple services. They'll call service 1, service 2, and service 3. The first service that responds wins, right? They hedge their bet by making the same call concurrently to multiple services, and they get the first one back. So here, I can say, let's say I can call host 1, right, equals do get all reservations, 1, right? And then 2. Okay, so I'm actually calling host 2. And you would use a service registry, something like that, to look up individual instances of the hosts. Now I've got 3 different versions of the stream. None of them are executing yet. And I want to tell Reactor, hey, give me the first one that returns back, and then use back pressure to dismantle the other 2. Okay? And there you go. That's how you would write that code. So now I'm guaranteed to have the fastest stream that wins. So if one of those streams is out to lunch, or it's got garbage collection issues, or it's down, or whatever, right? It's guaranteed that one of them will work in time. So you have some real interesting opportunities to be not only more robust systems, not only more scalable systems, but more elegant systems. All right, my friends, thanks so much for your time. Dziękuję. I appreciate it very much. Hope you got something out of this, and I'll see you on the internet. Thanks again.